The nature of enzyme action. So first, the formation of the enzyme substrate complex is essential for catalysis. So enzyme plus substrate, then enzyme substrate complex, then enzyme product complex, then enzyme releasing the product. Now first, the substrate binds to the active site of the enzyme fitting into the active site. So first, the binding of the substrate to the active site of the enzyme. Now the binding of the substrate. Now this substrate induces this binding. The enzyme induces the enzyme to alter its shape, fitting more tightly around the substrate. Now the active site of the enzyme, now in close proximity of the substrate, so that it breaks the chemical bonds of the substrate, and the new enzyme product complex is formed, and the enzyme releases the products of the reaction, and free enzyme is ready to bind to another molecule of the substrate and run through the catalytic cycle once again. Now this was the nature of enzyme, and factors affecting enzyme activity involves temperature and pH, concentration of substrate, concentration of substrate. Or okay, so these include temperature, pH, change in substrate concentration, or binding of specific chemicals that regulate its activity. So we study in this the inhibition process, that is competitive inhibitor. See the diagram, effect of change in pH and temperature. There is optimum pH, optimum temperature, enzyme activity on the y-axis, on x-axis pH or temperature. Now concentration of substrate on enzyme activity, you see substrate on x-axis, on y-axis it is velocity of reaction, which reaches to Vmax, and half of it is Vmax by 2, that is the Km value, that is Michaelis constant. There is competitive inhibitor, there is inhibition and inhibitor. A chemical is inhibitor, the process is inhibition. Now what is competitive inhibitor? When the inhibitor closely resembles the substrate in its molecular structure and inhibits the activity of the enzyme, it is known as competitive inhibitor.